Talking about similar polygons today. They're kind of like when we talked about congruent triangles. Polygons are just any shape, not just triangles. Obviously, they have to be enclosed. But for the basics of this section, it's pretty much what we did for our congruent triangles. So, in order to have similar polygons, we need to have angles that are congruent and sides that are proportional. Now, when we have congruent triangles, our angles and sides had to both be congruent. Well, now our angles have to be congruent, but our sides only have to be proportional. Okay, so they don't have to be the same, they just have to be proportional. Okay? So this thing right here is called a similarity statement. It's kind of like our congruency statement, where you can match up your angles by the letters, their place in their order, and you can do the same with sides, just like we could with our congruency statements, okay? Or you can look at your polygons, and so for our angle matching, if I said angle A, what angle of this shape matches A? G. So they have to be congruent. What matches up with B? Or I'm sorry, H?
B.
B. What matches with C?
I.
And D?
J.
J. So our angles have to be congruent. They can be matched, like I said, either with the picture or with our statement right here. Okay? Now our sides just have to be proportional. So we always write them in fractions, okay? If I say side AB from this shape, what side do I have to say from this diagram? GH, yeah. I say BC from the left one, what comes from the right one? HI. How about CD? IJ and AD? GJ. Okay. So like I said, they kind of match like we did for congruent triangles. This, where our sides are all set up equal in one row, is called the statement of proportionality, or of proportions. Okay, so sometimes maybe one question will ask you what angles should be corresponding and congruent, and what's your statement of proportions. That is an OR. Doesn't look like it. So you just set up which ones match into fractions, pretty much. Okay. Questions so far? No? Okay. Alright. So I want to know if my polygons are similar. Again, for them to be similar, my angles have to be congruent. Okay? I want to know if they are. Does F match something in my ABC triangle? Yeah, what does it match? A. Does E match something in my ABC?
B.
B. Do D and C match?
Yeah.
Yeah, remember we learned that if you know two angles in your triangles, the others have to be the same too?
Third angle theorem.
Third angle. Look at that. Third angle theorem.
No.
You remember stuff?
Oh. So are our angles congruent? All of them?
Yes.
Yes. So we'll check that out. The other thing I need for similar polygons are my sides need to be proportional. I need to check if they are. Okay? Well, if I started with side DF, that's 16, what side matches out of my ABC triangle?
AC.
AC, which is 8. So that gets one fraction. Okay? Match your sides, put them in one fraction. Well, if I reduce 16 over 8, what do I get?
4. It's just
Two.
two. Two. No, it's two. Two. Yeah.
2. So I need to make sure that these other sides are in the proportion of 2. Okay? If I start with 34 on top, which side matches 34 from my other triangle?
17.
Is that reduced to 2?
Yes.
Yep, so that one works. And my last side, 30. What matches with 30? 15. Does that reduce to 2?
Yeah.
Yes. So are they all in proportion?
Yeah.
Yeah. So now, can I say my polygons are similar?
Yes.
Yes. So are my polygons similar? Yes. And then it says write a similarity statement. Well, if I say DEF, to say similar, we use this little squiggly thing, kind of like what goes on top of the congruent statement. We don't have the equal signs. They're not equal. They're just similar. Okay? Now, again, we need to be careful which way we write this. If I say D first, what letter has to go first to the ABC?
B.
C. What matches with E?
B.
B. And what F has to match with A. So this is my similarity statement. The last thing it says, what?
Couldn't you just do ABC and D?
the other thing it asks is what our scale factor is, okay? Scale factor comes from, hold on, I can't talk and spell at the same time. Comes from our proportions, okay? What is the reduced number of our proportions?
2.
2, they're all 2. So our scale factor is just 2. Okay. Questions? Okay, we'll do another example. Are my angles congruent in this LMNO and QRST? Yeah, they're all right angles. My angles are congruent, good. What else do I need to check?
Proportion.
My sides. Let's say if I have 10, which one has to match with 10? 16 or 6?
16.
16. And I want to know if that's the same as 4 over 6. Well, 4 over 6 can reduce to what?
2 over 3.
2 over 3. Can I write 10 over 16 as 2 over 3?
Yeah.
No. So are they proportional? No. So we just say, are they similar?
Yeah.
No. Not similar. Okay, so in order for polygons to be similar, they have to have congruent angles, and your sides have to be proportional. Okay. Questions?
No.
This next example, are we okay? It's the same thing. Are we okay, or do you want to do this next example?
Okay.
Fine.
We're okay?
Yes.
Let's skip down to this. Triangle QRS is similar to triangle DEF. It asks, what are the pairs of congruent angles? Well, if all you're given is this similarity statement, you have to match up the letters just like we did when we had congruent triangles. So if I said angle Q is similar, what angle has to match with angle Q? D. If I said angle R, what would you say? Angle E. And last one, angle S, is similar to angle F. Angle S is similar to angle F.
Well, I thought it was in 25. I thought it was in 25 too.
Oh.
Oh, yeah. That just shows
It does look like 20.
not sure where we got.
You seen the 2 and then the 5?
Well, I see where you see it from, but where would you got the 25 from?
That's why I was
You never know.
I don't know. Okay,
Was this supposed
the
to be?
extended proportion for our ratios is that long fraction thing. All you gotta do is compare sides. Okay, so let's match the first two. If I say QR what do you have to say?
DE.
DE. The first two have to match. If I said RS, what would you say?
EF.
EF. And the last one, we'll say QS,
DF.
DF. It's a triangle, so we should only have 3 sides. Hopefully. Okay. Questions there? Okay. Word problems. Woohoo. Harold has a photograph that is 11 inches wide and 14 inches tall. Let's draw that. 11 inches wide, 14 inches tall. He wants to print at a reduced size to fit into a frame that is 10 inches tall. So I want it to be 10 inches tall. What I want to know what the dimensions of the new photograph. Well, if I want it to be 10 inches tall, I need to figure out how wide it's going to be. Okay?
So that would be 14 over 10 and 11 over x.
What do you guys think?
Yeah.
Yeah?
Well, 14
Yeah.
over 11. Yeah.
I told Miss Bundy showed us.
Of course,
It's
right?
really fun he's teaching our class.
Okay, you scared me because you like looked at me like,
No.
Nah, it's been
"Are
correct.
you sure?"
14 over 10 and 11 over x. How can I find how big x is? Cross multiply. 14x equals 110.
What's the math on that?
Divide by 14, and I'm going to give you the fraction kind because that's
Easier.
what I have written down. So I have to be 7 6/7 inches wide.
That's ugly.
It's an ugly number.
That is super ugly. Very
Super
ugly. Mucho feo.
See.
Muy
Yeah, but you could add that extra 1/7 and you would never be able to tell.
No funny.
But I want to fit in your frame. You
Well,
have to
that's
curl
such
the
a different
sides.
frame.
No, I feel like it would work a little bit. It just like be a little flexible, you know?
We don't want to cut off everyone's faces though.
No,
Okay.
but it's only like a little
Questions here?
No.
little percentage.
No, we're okay?
Like smaller than a
We're
finger.
good.
Okay. Alright. It tells me here that my polygons are similar. So that means my angles are what?
Same.
What did you say first? Congruent. Yeah, my angles are congruent and my sides are up here.
Similar.
My sides are what? Similar polygons have congruent angles and sides that are congruent. It starts with a P.
Polygon.
Parallel.
No, it's
Proportional. Proportional. Holy moly. Congruent angles, sides are proportional. If they were the same, it'd be the same shape and that'd be no fun. Okay. Well. So, match our angles. I said these have to be the same, yes?
Yes.
So to find x, all I gotta do is have 100 equal to 3x. How am I gonna find x? Divide by 3. Julia, Riley, up here. Divide by 3. X is 33.3. Repeating. That is x.
Pi. It's also my number.
Okay. I know this side is 12. What would I put on the bottom of that fraction? 4. 4. Yeah, match it up to this shape. 4. Equals, let's do this side first. Y. What goes on the bottom of Y? 2.
What the hell? Are you sure?
What? Positive.
Yeah, well, that's right.
Oh, yeah, you're right.
Okay, not yesterday, 2 days ago, we kind of talked about this. You don't have to cross multiply here. Cross multiplying drawing will always work, but you can also look at your fractions. How do I get from 4 to 12?
How about we just cross multiply?
Okay.
That's
No
just
problem. Alright, so 4y equals 24. How big is y? 6, which is the same as 2 times 3, which is what the other one is. But that's okay. You guys are all having fun. If y is 6, how big is this side?
Y is the what? That would
16.
be, what's
6
16.
plus J gets 16.
Yeah,
If you
16.
put 6 into 1.
3 times 6 minus 2 is 16.
How is that side longer than the bottom? It looks a lot shorter.
Because they're not drawn to scale. Okay, I still have my base proportion of 12 over 4. To figure out z, does z go with on the top or bottom?
Like Z.
Z.
Z,
That's easy.
I can't see where I'm looking.
16 is on top.
Oh, I thought you were on the next shape over.
B, hey, yeah, I still can't see now.
Z is at the bottom.
Z's on the bottom.
Yeah.
What goes on top of z?
16.
16. You kids like to cross multiply?
That's the kid.
12z equals how much? What's 16 times 4?
That's a tough number.
Really practically your age, Mr. This. What the heck?
Practically not.
Wait, how old are you?
64 divided by 12 is what?
Well, it's 12Z.
12z, yes, equals 64. 64 divided by 12 is 5 and 1/3. Cross off this one.
You write a Z like I write a 2.
That stinks.
Yeah.
Okay. Questions there? Okay, we're gonna do one more.
Let's do the last one.
No, we're gonna do the easier one.
Okay, fine. So do
Cross
we-
off this one.
Oh, we should do the harder ones because everybody likes to get us hard homework.
What? I don't.
Okay, how big is x?
30.
30. Angles are congruent, angles are the same. Those two match up. Looking at my left bigger triangle, what side do I know?
8.
8. What side has to match with 8 from this other smaller triangle?
5.
5. Where does the y go? On the top or bottom?
Top.
Top. These two go together. They're from the same triangle. What goes on the bottom of y? 2.5. How should I solve? Cross multiply. 5y equals 20. How big is y?
4.
4. Okay, questions there?
That was easy.
Okay. Skip all that front stuff. Okay. We got a bridge in San Francisco. It's called the Golden Gate Bridge. Well, the distance between the two towers is the main span. I want to know what the actual length of the main span of the bridge is. In my drawing, it is 6.4 centimeters. We got to convert that to meters. Okay, so let's set up two fractions. If 1 centimeter is 200 meters, and I know my drawing is 6.4 centimeters, I need to figure out how many meters that is in the real world. Okay, so same units should go on top and bottom. Okay. How should I solve this?
Cross.
Look at
Cross multiply. 1x equals, anybody super genius in their head know what 200 times 6.4 is?
Yeah.
Yeah, how much?
Wouldn't that be like? Let me type it in my calculator.
12,000.
Yeah.
12,000.
800.
Well, not 800, but
80.
or not 12,000, 1,000.
Yeah.
Look at that math. That's it.
She googled it.
Just kidding. Well, what happened to the centimeters?
What do you
Yeah,
mean,
so
care
do
about
we just
centimeters?
drop our like?
No, we were only trying to figure out how many meters. We're only trying to figure out that one.
So like, are we just pretending that the 6.4 is meters now?
No, because when you figure out, you're trying to find this, which is in meters, we know it is, because this is meters. You cross multiply. There's no like, what you're talking about is when you have conversions, like feet, inches, you have to multiply by inches to cancel this to get feet. Since there's an equal sign, it's not like this,
Okay.
because you're thinking science. But I get what you're saying. Cross this off.
Space needle.
Space Needle, last one. Okay, Space Needle in Seattle is 605 feet tall. Classmate wants to make a drawing on an 8.5 by 11 piece of paper. He decides to use the scale 1 inch equals 50 feet. So let's put that in one fraction. 1 inch equals 50 feet. That look like a 1? We'll do that.
Doesn't it?
So that's my scale. Well, how big is the actual Space Needle?
605.
605 inches or feet?
Feet.
Feet. So does that go on top or bottom? Bottom. So 605 feet. I want to figure out how many inches that is. Okay? What should I do?
Cross multiply.
Cross multiply 50x equals 605. You saying super geniuses know what that is?
I'm sure Maddie does. Yeah. Equals 605.
About
We gotta divide by 50. It equals 12.1. So, if it's 12.1 inches tall, but his paper is only 11 inches tall, is it gonna fit?
just draw on the desk.
Won't fit. Get a different scale or a bigger piece of paper. Okay. Questions?